This preview is for evaluation only and cannot be used for public screening.
Looking up on a dark, clear night, we see hundreds of stars. If we are far from city lights, we can also see a faint band of white light arcing overhead. To the Pawnee, this band of light was called the Path of Departed Spirits. To the ancient Hindus, it represented the Ganges River. The Egyptians saw a pool of cow's milk. The name we use for this band of light comes to us from the Greeks and Romans. We call it the Milky Way. The true nature of the Milky Way was unknown until Galileo pointed his telescope upward in the year 1609. In Galileo's words, "The Milky Way is in fact a collection of innumerable stars grouped together in clusters. Upon whatever part of it the telescope is directed, a vast crowd of stars is immediately presented to view." Galileo's monumental discovery changed the way we look at the stars and our place in the universe. Later observers concluded that because the Milky Way circles the sky in a narrow band, our solar system must lie inside a great wheel of stars. Sir William Herschel and his sister Caroline were the first to attempt to map the Milky Way. Their observations led to the conclusion that the sun lay near the center of an irregular disk that they referred to as the grindstone universe. However, they had no way of knowing the extent or nature of our galactic home. The size of the Milky Way and the sun's place in it would remain a mystery until the early 20th century. Until the 1920s, astronomers believed the Milky Way to be alone, floating in an empty universe. They believed that everything we see, stars, star clusters, and nebulae, are all part of our Milky Way. This idea persisted until a young astronomer named Harlow Shapley began to notice that open star clusters like the Pleiades are situated along the band of the Milky Way, while globular clusters like M13 in Hercules are scattered all over the sky, particularly in the direction of the constellation Sagittarius. Shapley concluded that most of the globular clusters are not grouped around the sun, but around a far distant and unknown center. The debate was ended in 1923 by one of Shapley's rivals, Edwin Hubble. Using the Mount Wilson Observatory, Hubble took a long exposure photograph of what was then known as the Andromeda Nebula. The photo revealed that the Andromeda Nebula was composed of thousands of individual stars. The following year, Hubble observed some of the stars in Andromeda pulsate at precise intervals. These pulsating stars, called Cepheid variables, can be used for determining distances. Hubble's discovery revealed two very important facts. First, that some of the faint smudges of light we see in the sky are actual galaxies like our Milky Way. And second, that these galaxies are unbelievably far away. Our Milky Way is a vast collection of stars known as a spiral galaxy. All the stars and nebulae we can see from Earth are part of this large-scale structure. All spiral galaxies are essentially flat disks with arms that spiral out from a central bulge. Surrounding the entire disk is a halo of globular clusters. The spiral arms are bright. They contain hot young stars newly emerged from their cocoons of dust and gas. The arms also contain the dead remains of stars that have run out of their hydrogen fuel. The central bulge contains mostly older, cooler stars. Because these stars are cool, they can survive for billions of years.
This preview
The
is
halo
for evaluation
consists mostly
only
of globular
and cannot
clusters.
be used for public screening.
These clusters are groups of thousands of ancient stars that are left over from the formation of our galaxy. A globular cluster contains tens of thousands of stars in the shape of a huge ball. A typical globular cluster is roughly 150 light-years across. The Milky Way's halo contains about 200 of these globular clusters. The Milky Way galaxy is almost unbelievably huge. The disk is approximately 100,000 light-years across, but is only about 1,000 light-years thick. Our solar system lies about 28,000 light-years out from the galactic center, almost 2/3 of the way toward the edge. But what of the other smudges of light visible in the night sky? What about the object that Edwin Hubble so carefully observed? To the naked eye or a small telescope, the Andromeda Galaxy is nothing more than a faint wisp of light, more like a nebula than a star cluster. Edwin Hubble's photograph of the Andromeda Galaxy showed a bright central bulge, a flat disk of spiral arms, and a halo of globular clusters. Images taken from the Hubble Space Telescope show the spiral arms of Andromeda contain hot young stars, as well as clouds of dust and gas that is very similar to what we see observing the Milky Way from Earth. Yet Andromeda is not the only example of a spiral galaxy for us to observe and study. In the constellation Canes Venatici, just below the Big Dipper's handle, we find M51, the Whirlpool Galaxy. Like Andromeda, it has clearly defined arms, a central bulge, and globular clusters. A survey of our night sky reveals dozens of these grand spiral galaxies. Yet not every galaxy we see is a spiral galaxy. In the southern hemisphere, we see two very large, faint clouds of light. These are the Large and Small Magellanic Clouds, named for Ferdinand Magellan, who first observed them as he circumnavigated the globe. The Magellanic Clouds are small companion galaxies to our Milky Way. Close observation, however, shows us they are very different from the beautifully structured spiral galaxies. They are irregularly shaped, although they contain young massive stars and clouds of dust and gas. The Magellanic Clouds are beautiful examples of irregular galaxies. Elsewhere in the sky, we find another kind of galaxy, the ellipticals. These galaxies resemble the central bulge of a spiral galaxy without spiral arms. Elliptical galaxies also differ in the age of their stars. Since ellipticals have very little dust and cool gases, they tend to have very little new star formation. As a result, ellipticals contain many older, cool stars and no young, hot blue stars. Like our Milky Way, the Andromeda Galaxy has two companion galaxies. Both of Andromeda's companions are elliptical galaxies. The number of galaxies we can see with the naked eye is extremely small. Telescopes and long-exposure photographs reveal more galaxies. Yet an estimation of the number of galaxies in our universe was not fully realized until 1995, when the Hubble Space Telescope pointed its cameras to a small patch of sky near the Big Dipper.
This preview is for evaluation
This is the
only
Hubble
and
Deep
cannot
Field.
be used for public
It
screening.
examines a piece of sky no larger than the size of a tennis ball seen at 100 meters. Nearly all the 3,000 objects in this image are galaxies. 2 years later, the Hubble took a similar image looking at the southern hemisphere. It too revealed thousands of galaxies. Is the entire sky like these two tiny slices imaged by Hubble? This question was answered in 2004 when it stared at a piece of sky just southwest of Orion, the Hunter. The Hubble Ultra Deep Field image contains approximately 10,000 galaxies, some of which are the most distant objects ever imaged by an optical telescope. Clearly, the universe is filled with galaxies. It is obvious from the Hubble Deep Field images that some are closer to our Milky Way and some are much further away. But are galaxies uniformly distributed through the vastness of the universe? The presence of the Magellanic Clouds and observations of the Andromeda Galaxy indicate that galaxies can have companions, just like stars. These companions are bound to their parent by their relentless force of gravity. Spiral galaxies are often associated together in clusters. Our own Milky Way is part of such a cluster known as the local group. Some groups can be associated together in superclusters. The local group is part of a supercluster known as the Virgo supercluster. The Virgo cluster is just one of thousands of superclusters. As we fly further and further away from our Milky Way, each of the faint dots we see is not an individual star, but an entire galaxy, each composed of billions of stars. As we fly further and further away, we begin to see the large-scale structure of our universe. At this distance, we find chains and sheets of galaxy clusters separated by great voids of empty space. The gaps between these wedge shapes represent where dust and gas from our own Milky Way block the view of these large-scale structures. For thousands of years, Earth resided at the center of the universe, at least in the minds of our ancestors. Galileo's observations with a telescope proved that Earth was not at the center of our own solar system. Yet 400 years would pass before our place at the center of the Milky Way would be challenged. Thanks to the work of Harlow Shapley, Edwin Hubble, and others, we now know that our solar system is not at the center of the Milky Way. We also know that the Milky Way is just one of billions of galaxies, each containing billions of stars. Yet for every question we answer, 10 more crop up. The true nature of the universe, and ultimately our place in it, continues to challenge us.